Today, we're stepping inside a colossal manufacturing facility where millions of baseballs are produced every single day. Stay with us as we reveal the hidden factory world that turns simple materials into championship-ready baseballs.
Inside a colossal industrial complex stretching across acres of steel and concrete, a factory runs without rest day and night, producing one of the world's most iconic sports objects, the baseball. The journey begins at the raw material arrival zone, where massive cargo trucks roll into the facility, carrying compressed blocks of natural rubber, synthetic polymers, premium cowhide leather, industrial-grade thread, adhesives, wax compounds, and chemical coatings. Once approved, giant rubber blocks are fed into towering industrial mixers that resemble machines from a steel mill. Inside, rotating steel blades shred the rubber, while heaters raise the temperature until it softens. Chemical stabilizers and elasticity enhancers are injected automatically, ensuring each batch has consistent flexibility and strength. Sensors monitor viscosity, temperature, and mixing speed in real time. After blending, the molten rubber compound flows into steel extrusion systems that push it into long, cylindrical strands. These strands are sliced into precise segments by automated cutters, each segment weighed digitally to ensure uniform mass. Forming perfect spherical rubber cores. Steam rises as the molds heat the rubber, locking its shape. Once released, the hot cores travel on cooling conveyors where industrial fans blast cold air to stabilize their structure. Any core with surface defects or weight imbalance is automatically rejected. Next comes shaping and trimming. Robotic blades remove excess flash from the molding process, smoothing every surface. Laser scanners rotate each core, mapping its geometry to ensure perfect roundness. Now the real engineering begins, the winding process. Each rubber core enters a high-speed yarn-wrapping machine where ultra-strong wool and polyester threads wrap around it at thousands of revolutions per minute. Layer after layer is added under precise tension control. This winding stage is crucial because it determines the final weight, bounce, and energy transfer of the ball. Too loose and the ball becomes dead. Too tight and it becomes dangerously hard. Computer systems adjust tension dynamically. By the time winding is complete, each core has accumulated kilometers of thread, building a dense, spring-like structure. After winding, the cores move to the leather preparation zone. The leather panels are heated and softened in steam chambers, making them easier to mold. Robotic arms apply industrial adhesive to the wound cores before wrapping the leather tightly around them. The leather stretches as it is pulled into position, hugging the spherical shape perfectly. Here, massive steel cutting presses stamp figure-8 shapes from premium cowhide hides. Operators monitor magnified camera screens to verify stitch depth, spacing, and alignment. The stitched balls then enter shaping presses where rotating steel molds roll them repeatedly, flattening raised seams and ensuring perfect symmetry. With structure complete, the balls enter the finishing department. They roll through massive polishing halls where giant buffing wheels spin rapidly, smoothing the leather surface. Fine dust fills the air as ventilation systems extract particles. Next, the balls pass through automated wax coating tunnels where a thin protective layer is sprayed evenly, enhancing durability and grip. Heated air dries the coating instantly. Coloring comes next. In massive paint booths similar to automotive factories, robotic spray guns apply the signature off-white color. Sensors monitor paint thickness while powerful fans remove fumes. Any uneven coverage triggers rejection. Now begins one of the most intense stages, inspection and testing. Baseballs travel under high-speed cameras that scan for surface flaws. Laser systems measure diameter. Digital scales check weight to the milligram. Approved balls move forward, while rejects drop into steel bins. The approved balls then enter brutal stress testing labs. Hydraulic presses crush them to test compression recovery. Pneumatic cannons fire them at steel walls to measure impact durability. High-speed spinning rigs rotate them at extreme RPM to detect internal imbalance. Mechanical claws pull on seams with violent force to test stitching strength. Abrasion drums spin balls against rough surfaces, simulating years of gameplay. Only balls that survive every test earn certification. Certified balls receive laser-etched approval marks before moving to packaging lines. Automated machines sort them into exact quantities. Shrink-wrap tunnels seal packs tightly. Robotic arms stack boxes, while glue machines seal cartons instantly. Forklifts carry stacked pallets into towering warehouses where inventory systems assign destinations. Container loading robots pack pallets into steel shipping containers, which are trucked to massive ports. Harbor cranes lift containers onto cargo ships bound for every corner of the world. Weeks later, containers are unloaded at international ports, moved to regional distribution centers, and sorted again. Trucks deliver them to sporting stores, markets, and stadium suppliers.